Okay, so it's recording and it's a div3 round. So let's go. Yeah, that's okay. Calls in array dense if the greater of any adjacent element is not more than twice bigger than the okay. Hmm. Adjacent elements, right? Like if this is not satisfying, a number in between. Hmm. A is also very small, so just brute force will work. And yeah. Oof. A very good start to a contest. No. 512103. Okay. You're given an array n, which is divisible by 3, and an array. You're given an array. You're given a number n and an array a there of length n. In one move, you can increase any of the array element by one. Okay. You can choose the same index I multiple times for different moves. Let the node split node by C0, C2, the number of numbers from the array that have remainder. Hmm. Okay. Okay, so I have some zeros, some ones, and those like this 5, it's 2, it's 1. Make this 5 equal to 2. this all should be equal, right? So all should be equal to me. This should be equal to n by 3, right? So it's not, this should be equal to 3, 3, 3. So to increase one, I'll just add this 3 and it will be 4. Hmm. Just move it ahead and make it less than equal to 3. Just move it ahead and make it equal to 3. And this way I'll have my first case. 114. This is okay. This is okay. Okay. So this is not okay. Uh, why this is 3? Okay. I'll just let's see. Oh, Godspeed. Nice. So I think C is not that tough. You're given a positive integer x. Check whether the number x is representable as the sum of the cubes of two positive integers. Formally, you need to check if there are two integers a and b such that a cube and b cube should be equal to x. And if x is this, then I need to iterate in the worst case till 10 to the power 4 types, right? hack me if you can, and I'll be very happy if I get hacked on C, which I can get obviously. Me, obviously. D it is. Let's go. Permutation is a sequence. We know permutation did this. Hmm. Polycarp has a permutation is a sequence of integers n integers from 1 to n in which all the numbers occur exactly once. Okay. So for example, okay, recently if you have permutation this of length n, Polycarp like trees more than permutation, so he wants to transform a permutation into a rooted binary tree. He transforms an array of different digits into a tree as follows. The maximum element of the array becomes a root. The element to the left of the maximum forms a left subtree. Cool. Which is built according to the same rule but applied to the left part of, but there is no element to the left of this. This is the maximum 3 and the maximum between this is 4. Then for this is 2 and 1. Depth of the vertex, status, path from the root to the vertex numbered v, find the depth of each value. So this is, I think, why n is very small. I don't think there is a need for the n to be small. Okay, so you are telling me that don't use the uh, RMQ and just iterate n square and do the favor, right? Okay, so we can do something like, mm, let's say we have this. I'll just LLR. This is my maximum, and then I'll just this and for now, at last, let's say there is 3 element, and just go for this. Do nothing. Yeah, so it's easy divide and conquer types. Maybe I have overcomplicated the Ryan range. Ryan. Maybe I have overcomplicated the problem, but this is the first thought I got, so it's okay. And I don't have to print this. I think it will work. 0 1 3 2 3. Let's go. E. Okay, so 10 minutes. Yeah, nice. Let's see. Championship in. Uh, I took a hell lot of time in finding the cube root. That's fun. Okay. So a championship is held in Berlin in which n player participate. The player with the number I has AI tokens. Okay. So championship consists of n minus one games. Let's begin. Game theory is here, which are played according to the following rules. In each game, two random players with non-zero tokens are selected. That's a very small. uh, Okay, so yeah. Uh, each game, two random players with non-zero tokens are selected. The player with more token is considered the winner of the game. The winning player takes all the losers token. The last player with non-zero token is the winner of the. Okay, so all random decisions are made during the championship are. Then one of the options of for the game is hmm, so it's this now. So and is this a the permutation? No. So we have AI number of tokens each player have. Okay. So during the first game, second game, fourth game, and this is the result, and this is the result. Okay. That is have a non-zero probability of winning championship. Okay, so let's have uh, sorted order. Okay, only a minute. Sorry, false. Okay, cool. What's the standings now? It's okay. So it took me 11 minutes. Yeah. Can I get it really? I don't think so. Okay, let's read this. Polycarp was gifted an array A of length n. Polycarp consider an array beautiful if there exists a number C such that each number in the array occurs with Polycarp was gifted an array A of length n. Polycarp consider an array beautiful if there exists a number C such that each number in the array occurs either 0 or C times. Okay, so Polycarp wants to remove some of the elements in A to make it beautiful. If n is 6, so it make every or C times and uh, okay, so we can decide C. So it took 2 times, 1 times, 1 times. We can remove all the elements, right? First of all, so my answer will be at max n. what I can do. Hmm. To make everyone 6, I need to bind a search on an element, and I can't increase it, right? I can only delete it all. Makes sense to me. Hmm. Uh, till this point, and after this point, I need to remove all, right? So I need to remove ind plus my remaining. It's not the remaining, it's like, I think it's correct. Yes, it should be. Wrong on 2. Okay, so my answer is 4 now, na? Yeah, makes sense to me. And obviously, never mind. It's not rated for me at least. So, let's wait. Let's solve this. Okay. Uh, Polycarp was dismantling the attics and found an old floppy drive in it. A round disk was inserted. What's the status? Nice one. Problems are easier. Godspeed. Polycarp was dismantling his attic and found an old floppy drive in it. A round disk was inserted into the drive with an integer written on it. Put the numbers into an array. At the drive following algorithm. The drive takes one positive number and x as input and put a pointer to the first element of the array. After that, I started reading the disk. Every second, moving the pointer to the next element, counting the sum of all the uh, elements that has been under the pointer. Okay, since the disk is round in the array, the last element followed by one, obviously, as soon as the sum is at least x, the drive will shut down. Raghav wants to learn more about the operation of the drive, but he has absolutely no free time, so he asks you M questions. To answer the algorithm, you need to find how many seconds the drive will work if you give it xi as input. Okay, please note that in some cases the drive can work infinitely. Mm, 1 minus 3 and 4. My current sum is 1. Then my sum will be like minus 2, and then my sum will be uh, 2, right? So this will be my sum. So if I have something like 8, then what I can do is I can simply uh, move this, and my, let's say my this is 9. So I can simply do 9 by 2 times, so it will confirmly move, right? And by 2 will give me 4. So yeah, n minus 1 times 4, like 1, 2, then 3, 4, 5, then 6, 7, 8, n times this minus 1, n times 9 by 2 minus 1, 1, 2, 3, 4, 5, 8. Now it's Yeah, so 3 4 11, it will be here, then I need to find 1, right? For 1, what I can do is I can just binary search the uh, number 1, so it will give me either this or this, right? So 1 is present, yes, so it will be IND. But there's some cases that it won't be like, okay, I got it maybe. Oh shit, this is wrong, no? Oh, never mind, I had solved it. It was just this stupidity. Like, okay, I thought if my answer, if my current sum is less than the uh, less than equal to 0, then obviously I can't increase my sum, right? So my answer will be uh, like it will keep on rotating. But what if I found my the uh, found the sum which I need to find in the first uh, iteration in itself? So yeah, that was my mistake. So first I have to check if it is less, then I need to find if there is my answer present. If not, then I need to check that my uh, my current, which is the total sum till the end, is less than equal to 0, and then I need to check if okay, so if not, then my answer exists for any x greater than current, right? So yeah, that's the in solution. So yeah, I can just I'll go through the problems one by one, like a quick recap. Obviously, I won't be explaining all the uh, solutions in detail, but yeah, I'll explain all the solutions in. So the first problem was uh, okay, yeah. So it says like if you have I and I plus 1, and let's say you have mx maximum of these two and mn minimum of these two, so it say that mx should be less than equal to 2 times mn. So and if it's not, then what I can do is like this is mn and this is mx, I can place some numbers, like, right? So what is the maximum number I can place? I, I can place 2 mn, and then here I can place 4 mn, then here I can place 8 mn, right? So I'll just keep on placing these numbers until I find something like 2 to the power k mn, which satisfy this equation, right? Like mx is less than equal to uh, 2 to the power k mn, right? And in this case, I'll just add k minus 1 to my answer because I have added k minus 1 elements between these. So that was the uh, solution to this. You can see my code if you want. Okay, so this is balanced remainder. Yeah, so what I did is let's count all the numbers having remainder 0, 1, and 2. So simply what I can do is let's say my count of 0, count of 1, and count of 2. So if this is my okay, so I need to make all these equal. So it is very obvious that it will be equal to n by 3. So this should be n by 3. This should be n by 3. This should be n by 3. So if it is less than equal to n by 3, then I'll just leave it. If it is greater than uh, n by 3, then what I will do is I'll just make it n by 3, and all the remaining I'll shift ahead, right? So if this is also now equal to is greater than n by 3, then I'll shift all these here, and make it n by 3. So in one iteration I'll get my answer, but I have used two iteration to be, just to be on a safer side. Yeah. This is very, basic problem. Like you have a number n and you need to find if it's uh, can be represented as a cube plus b cube. So the main point is it's constantly 10 to the power 4. So the maximum my a can be is 10 to the power, it is 10 to the power 12. So maximum my a can be is 10 to the power 4. So I can just iterate through all the a, right? And I'll just uh, find my remaining portion, which is my n minus a to the power cube. So now if my this remaining is a perfect cube, then I'll have my answer, otherwise I won't. Uh, okay, so I like this question. Yeah, uh, I like this problem. It was Yeah, it was okay. Like we are given this array, right? And what he says is like what I look on this is, let's say I have this L and R, and so I'll find the maximum. Let's say this is my maximum. Now what I need to find is I need to find uh, the element which is less than this maximum, which is obvious, and I need to find the maximum element in this range and maximum element in this range. And what I'll do is, let's say this is mx1 and this is mx2. So uh, I'll just make a path between mx1. I'll just connect mx with mx1 and mx with mx2, and so on. And then I'll just have to do the same here. So like uh, now I'll just call uh, do of L to this. Let's say this is my IND, L to IND minus 1, and do of IND plus 1 to R. This 2 is like my divide and conquer. Okay, so yeah, so this way I'll just have I will build my tree. Okay, so like let's say this is my tree, and then we can easily run a BFS to find the depth of each node. So yeah, it was a very basic problem, but um, uh, a good one, I guess, for a Div3. So this is participate. Okay, so that's it, right? Yeah. So this was a okay, like we have array. Let's sort it, right? So obviously the lowest uh, the lowest uh, what's that token, yeah, so the lowest token a person has, he can't win obviously. So to for a1 to win, we need some conditions, right? These conditions include a0 plus a1 should be greater than a2, a0 plus a1 plus a2 should be greater than a3, and so on, a0 till a of n minus 1 should be greater than an. Like this should be these all should be true for I. So if I keep on checking these stuff starting from the my right part. Okay, so let's say I am on I. So and let's say that this condition don't hold for I, so I can say that for all the elements behind this, they can't win, right? So yeah, so uh, I just need to find that I where the condition hold, and all the elements to the right of it will win. And I think we need to print I need to print the indexes. So yeah, we can just make a pair, right, of value and index, and then sort it and then do these stuffs. Yeah. Okay, so F was Polycarp was gifted an array A. Okay. Uh, okay, yeah. So F was also not that tough. Like we have some uh, numbers, right? And we are concerned with their occurrences, right? So let's make a frequency array. Uh, Array or anything, I you can't make an array, so you have to use a map. So let's make a map of the occurrences. Then what we are concerned with the occurrences, so what I did was, uh, let's say we have an array which have all the occurrences, like we have some number which has occurred 3 times, some number which has occurred 5 times, some number which has occurred 9 times, and some number which has occurred 10 times, right? Let's say 5 and 5. So if I need to make all the element equal to 5, I have to remove these elements, and obviously I have to remove some elements from this part and make these element equal to 5 and 5. So I need to remove 4 plus I need to remove 5 plus I need to remove this, which is 3. So yes, so what we can do, we can have a prefix sum from the starting, and we can also have a prefix sum from the ending. And for 5 we can bind search the other 5, right? And we have this, then we can easily uh, uh, do the prefix sum till my left of I, left of I. Let's say this is int, which is this is I. So left of int plus prefix of right till right of int. That's it. And, and minimizing the answer will give me the answer at the end. Okay, so yeah, this was also a very basic problem. Like we will make a prefix sum. Okay, uh, so uh, I'll make a prefix sum of the sum which I have till my current I, right? So what I can do uh, if my sum uh, is greater than my previous prefix sum, then I will update my prefix sum with the sum. Otherwise, instead of decreasing, like I have 2, 4, and minus 3. So what I can do is 2, 6, and I'll just use 6 instead of my prefix sum here, which is 3. So I don't need to decrease, right? So this way I'll have my prefix sum which is sorted. Okay, so now this is very easy to observe. Like if we have some number, let's say my ending sum is 2, right? And I have 9 with me as inquiry. So uh, I know that I have to uh, repeat the disk for I by 2 times, right? So I have to move my pointer n into I by 2 times minus 1, because I am starting from here, right? So yeah, and after that I just left with 1, so I can just easily bind a search and adjust and and print my answer. So, and one important observation, like when my answer will be minus 1, where I was making a mistake, is like if your current is less than equal to 0, you know that your answer will be minus 1, but not always, right? So let's say I have 2, then minus 1, then minus 4, right? So in this case, my current, which is my sum at the end, is uh, 2, 1, and this is minus 3. So my sum is minus 3, right? So I know that after one iteration, my current will keep on degrading and degrading, right? So my answer, but what if I have a query with 2? So I'll find this 2 in the first go, right? Yeah, or I have a query with 1. So I'll find this in the first go. Right. So I need to check for the first iteration if I can find this, and after that, if like like uh, like the number which I have uh, is greater than my current, then I can't find that number if my current is less than equal to 0. So yeah, so this was the mistake I was doing all the time. Otherwise, uh, I had the solution, right? I had the solution. Uh, Never mind. So that's it. I hope you like the screencast where I haven't talked much and I have performed really bad. So I hope this was helpful to you, and um, thank you for watching.